Okay, so we are looking at parallel and perpendicular lines today. I've just did a little bit of a sketch here to show parallel lines will never cross each other. They'll just stay parallel to each other, so same distance in between the two lines. Perpendicular lines, they do cross, so we have a line and another line, and they're crossing to make a 90-degree angle. So we're going to start by looking at this example here, investigating parallel line segments. That's what we'll look at first. And we have here line segments. We have AB, CD, EF, and a GH. So what we're going to do first is just look at the slope for each line segment. So again, rise over run. When you have segments like this on a graph and you don't have their endpoints, you can just use a rise over run. They're all going down, all right? So like we talked about earlier, when the line is going down from left to right, we know that our slope is going to be negative. All right, so counting from E to F, our height or our rise is 1, 2, 3, so -3. And our run is 6. 1, 2, 3, 4, 5, 6. All right, you can reduce that fraction to -1/2. Let's look at our next line segment, CD. So again, from C to D, we are going down 1, 2, 3. So -3 and then over 6. And again, that can be reduced to -1/2. All right, if you continued that for EF and GH, so EF and GH, they all have the same slope of -1/2. All right, so if you had lines given and you had to figure out if they were parallel, you would know that they're parallel if their line segments have the same slope. All right, same slope means they would be parallel. So that's how we know if two lines are parallel. Next, we're going to look at perpendicular lines. All right, so let's just make a note here that parallel lines, they have the same slope, the exact same slope. All right, so in that example, all of the slopes were -1/2. Okay, so let's take a look at this investigation next here. We're looking at an example here. Let's look at this line segment here. A to O. O is representing the origin. All right, so if we look at our slope for OA, first of all, the line is going up from left to right, so we know that our slope will be positive. Let's look at our rise. So our rise is 1, 2, so +2, and our run is 5, so 1, 2, 3, 4, 5. So our slope is 2/5. So next we're looking at this line here. It's OC, and this line is intersecting OA, and we have to look at the slope of that just to see what is happening. So when we calculate OA, we notice here that the line is going down, so we know our slope will be negative. So let's count our rise. 1, 2, 3, 4, 5. So it's a -5, and the run horizontal is 2. 1, 2. So it's 2. So what we notice from this investigation is that when two lines are perpendicular, we have what we call a negative reciprocal. All right, so recall that reciprocal means flipping the fraction. So 2/5 is flipped to 5/2, and it becomes negative. If you multiply the two slopes together, so 2/5 multiplied by -5/2, your answer will be -1. So anytime two lines are perpendicular to each other and you multiply their slopes together, you will always end up with a -1. All right. So that is what we can say about slopes of perpendicular line segments. The slopes of perpendicular line segments, they have a product equal to -1, and it's also called a negative reciprocal. All right, so the next example here is for point B. So if we look at B to O and then DO as well. So if we look at our slope here for B, O to B, the line is going downward. Our slope therefore will be negative. Our rise is 1 and our run is 1, 2, 3, 4, 5, 6. So our slope is -1/6. And then let's look at our slope of O to D. Our rise is 1, 2, 3, 4, 5, 6, and our run is 1. All right, so our slope is 6/1. So again, if you multiplied -1/6, multiply it by 6, we end up with -1. Okay, so negative reciprocals. So here our slope was already negative. It was -1/6. So this would become, in this case, 6/1, and it's positive. All right, so I'm just going to write that down here. That perpendicular lines, the product of the slopes is -1. As well, I'm just going to make a note here that is also called the negative reciprocal. All right, so let's take a look at the next example. So we're looking at example number 1. It's on page 539 under lesson 6, parallel and perpendicular lines. So we are given a line segment AC, and we are told that it has a slope of 3/4. So slope is 3/4. All right, so we call that little m stands for slope. All right, so first question with this information is write the slope of the line segment GH, which is parallel to AC. So GH is parallel to AC. If they are parallel, we already know the slope has to be the exact same. So therefore the slope of GH has to be 3/4. All right, because they are parallel, and we know that parallel lines will have the same slope. Okay, part B, write the slope of the line segment BF, which is perpendicular to AC. All right, so our slope for AC was 3/4. To figure out the slope of a line that's perpendicular to AC, we're just going to take the negative reciprocal. So we're going to flip the fraction to 4/3 and make it negative. All right, so the slope of BF therefore is -4/3. So the slopes of two lines are given. This is question number 2 on page 539 for lesson 6, parallel and perpendicular lines. And so we're given the slopes of two lines, and we have to figure out, are the lines parallel, are they perpendicular, or neither? So the first example, we have two lines. Slope of line 1 is 1/4, and the slope of line 2 is 3/12. All right, so first glance, you'll see, okay, they look totally different. Maybe they're not parallel or perpendicular. But you have to look at your fraction here, 3 over 12. That can be reduced. So if you reduce 3 over 12, that's actually 1 over 4. All right, in reduced form. So now we can see that the slopes are the exact same for line 1 and line 2. So therefore, they are parallel lines. Okay, and then B, we have line 1 is 5 over 7. And the line 2, the slope for line 2 is 14 over 10. Okay, so again, first glance, they look different, but check your fractions. This fraction here, 14 over 10, it can be reduced. We can reduce it to 7 over 5. All right, so it's 5 over 7 for the first line, and our second line is 7 over 5. This is a trick question. This is neither. It's still not perpendicular, okay, because this is not a negative reciprocal. Okay, to make them perpendicular, this had to have been negative 7 over 5. All right, and because it's not, they are not parallel, they are not perpendicular, they are neither. All right, let's take a look at our next example. All right, so we have 2 points here. Point P is at 4, 7. And our second point, point Q, is at 6, negative 2. All right, so the first thing we have to do for this is find the slope of the line segment. All right, so let's find the slope. So again, remember it's rise over run. So rise, you use your y values. All right, so either way, you can do 7 minus negative 2, and then 4 minus 6, or you can do negative 2 minus 7, and then 6 minus 4. Just make sure you do them both the same way. So I'll just use PQ to find the slope. PQ, so 7 minus negative 2 over 4 minus 6. Okay, so that gives me a positive 9, and 4 minus 6 is negative 2. All right, so a slope of 9, or negative 9 over 2. All right, all I've done is bring the negative sign up to show that it's a negative slope. So that's the slope of the line. The next part of the question asks parallel to line segment PQ. So find the slope of a line segment that will be parallel to line segment PQ. So to be parallel, the line segment has to have the exact same slope. So the slope would have to equal to negative 9 over 2. All right, and then question B, find the slope of a line segment that is perpendicular to PQ. All right, so perpendicular, we take the negative reciprocal. So this is already a negative slope. So the first thing we'll do is flip it, just like that. It's already negative, so the negative reciprocal here would be positive. To do a check, you can do a check by multiplying negative 9 over 2 times 2 over 9, and it has to equal to negative 1. So negative 18 over 18 gives me -1. So that's correct. All right, so just to reiterate the rules here one more time. Parallel lines, the two parallel lines will have the exact same slope, and perpendicular lines, you take the negative reciprocal. If you take the product of both of those slopes, you will end up with -1. All right, so we're looking at this next question. It's question number 4 under lesson 6, parallel and perpendicular lines. So triangle LMN has coordinates L. I'm just going to write them down here. Coordinates L are -4 and 2, and coordinates M is -2 and 7, and the coordinates for N are at 1, 0. So the first thing I'm going to do is plot this out, plot the points on the graph, and my scale I'll just use is going up by 1. Okay, so -4, 2, 1, 2, 4, up 2. So there's my point, L. Next one is -2 and 7. So -2 and up 7. So right there, that's point M. And the last one is at 1, 0. So over 1 and 0 for Y. So that is the plots. Next, I'm just going to connect these because it did tell us that it's a triangle. So I'm just going to connect them with a ruler. All right, there's our triangle. Okay, so I've plotted the points. Use the slopes to show that the triangle is right angled at L. So here is L. We have to prove here that at L that it's a right angle. So we can do this by showing LM and LN are perpendicular. All right, so let's find our slope for LM. All right, so I'm just going to go 7 minus 2 for the rise. And my run is -2 minus 4. -2 minus -4. All right, make sure you're writing it out correctly. So it's -2 minus -4. So that gives me a slope of 5/2. All right, so that is the slope for LM. And also note it is positive, which is what we should see because it is going up from left to right. Next, let's look at the slope of LN. All right, so this line here, L to N. All right, so using my 2 points here, I'm using L and N. So 0 minus 2, and then 1 minus -4, and I end up with -2/5. All right, so doing a quick check to prove that they are perpendicular, you can multiply them together, the two slopes, so 5/2 times -2/5, that gives me -10/10, which is equal to -1. So therefore, they are perpendicular, and therefore it is right angled here. So it is right angled because perpendicular lines make a right angle. All right, so we can say here at the end that the lines LM and LN are perpendicular. Oops. Therefore, angle L is 90 degrees. That's good enough. Since it's 90 degrees, we know it's a right-angled triangle at L. Okay, so our last example for this lesson on parallel and perpendicular lines, we are looking at two lines. This is number 5. We have two lines that have slopes of -3/4 and k/5. So meaning the first line has a slope of -3/4 and the second line has a slope of k/5. And we have to figure out what is the value of k. So firstly, what would the value of k be if the lines are parallel? And what would the value of k be if it's perpendicular? All right, so when it's parallel, we know that both lines, they have to equal, their slopes have to equal each other. So we'll just make that equal to each other. So we'll make -3/4 equal to k/5 because we know that both lines have to have the exact same slope. Okay, to figure out the value here, you can just use cross multiplication. So you can do 4k, it's equal to -15, and then divide by 4 on both sides. And the value of k would be -15/4. All right, so that's what this value here would be. If the two lines are perpendicular, we know that if we multiply the two slopes together, they have to equal to -1. So we can multiply the two slopes together. -3/4 times k/5 has to equal to -1. All right, so that multiplied together, that's -3k/20 is equal to -1. I'm going to multiply by 20 on both sides. All right, that gets rid of that fraction like that. And we have -3k is equal to -20. Divide by -3 on both sides. That leaves me with k is equal to 20/3. It's a negative divided by a negative, so 20/3.